I'd like to take a look at a couple of example problems having to do with right triangles, and specifically examples that will use the Pythagorean Theorem. Okay? So the first example I want to look at here is a rhombus. Okay? They're giving me the lengths of the diagonals of the rhombus. The diagonal lengths are 18 and 24 centimeters. I want to find the perimeter of the rhombus. All right? So I want to make a quick sketch. And I want to draw in my diagonals here. This does require you to know something about diagonals of rhombuses. A couple things to keep in mind. Number one, a rhombus is a parallelogram. Okay, so the diagonals are going to bisect each other. And what that tells me is the short diagonal is getting bisected. We've got lengths of 9 and 9, half of 18. And the other diagonal is 24 units. It's going to be divided in half. You've got lengths of 12 and 12. And here's the other key. Diagonals of rhombuses are perpendicular. So we've got right angles here, which means I have little right triangles. In fact, I have 4 congruent right triangles. All right. So at this point, all I need to do is use the Pythagorean Theorem. I can make that side x, 9 squared plus 12 squared is going to be equal to x squared. That's 81. That's 144. If you add those together, 81 plus 44 is going to give me 225 for x squared. When we work through that, that means x is going to be 15 units. Okay, so I've got little right triangles with side lengths of 9, 12, and 15. We've got 9, 12, 15 over here. Remember, it's a rhombus, so all 4 sides are going to be 15. We have another 9, 12, 15 here, and we have another one there. Go back, check the original question. Original question asked me to find the perimeter. Okay, so we've got 4 side lengths of 15. That means the perimeter is going to be 60 centimeters. Don't forget the units if you're given units in the question. All right? Second example. A right triangle has a long leg that's a unit longer than its short leg. The hypotenuse is a unit longer than the longest leg. And I want to find out how long each leg is, okay? Or they could ask me for the perimeter, or they could ask me for the area, lots of different things that I could possibly be asked, all right? Really important to get a diagram. They give me no side lengths, okay? So they say that one leg is a unit longer than the short leg. So maybe start out with the variable of x, representing the short leg. The long leg is 1 unit longer, so it's going to be x plus 1. All right, the hypotenuse is 1 longer than that, which means it's going to be x plus 2. Okay, you're probably at this point used to the idea that you're going to be given 2 out of 3 sides in a right triangle, and you're going to be finding the third side. That isn't required. That's a big focus in this section. Okay, they kind of assume that you've worked with the Pythagorean Theorem in previous courses. Okay, so the big focus here is really going to be on the idea that you can fill variables into the Pythagorean Theorem. As long as you have one variable, you should be able to fill it in and get one equation that's going to be solvable. Okay, but it may be a little bit more complicated than things you've had in the past. So let's take a look at this one. The theorem says a leg squared plus a leg squared is equal to the hypotenuse squared. So that's going to look like x squared plus x plus 1 squared is equal to x plus 2 squared. Okay? And here's where your Algebra 1 experience is going to be really important. Remember that exponent rules apply to multiplication and division. They don't apply to addition and subtraction. Okay? I can't square this and say that the answer is going to be x squared plus 1. Okay? I can't square this and say it's going to be x squared plus 4. Okay? When something's being squared, it's being multiplied by itself. All right? So when I've got x plus 1 squared, it's being multiplied by itself. That's a FOIL problem. Okay? We're going to get x squared plus x plus another x plus 1. That's x squared plus 2x plus 1 when you FOIL that out. Okay? X plus 2 squared, same kind of thing. That's also going to be a FOIL problem. All right? So I've got this x squared. This squared is x squared plus 2x plus 1. Okay? If you square the quantity x plus 2, that's quantity x plus 2 times the quantity x plus 2. That's going to be x squared plus 2x plus another 2x plus 4, okay? That's x squared plus 4x plus 4, all right? The equation here is going to be pretty complicated, okay? We've got a bunch of x squared terms. We're going to have to try to simplify this down, all right? So if we simplify over here, we've got 2x squares. We've got a 2x. We've got a 1. On this side, of course, x squared plus 4x plus 4. Remember, when you're solving a quadratic, you want to get everything on one side. You want the equation equal to 0. Then you can use the quadratic formula, or you can factor. Those are kind of key things that you worked with back in Algebra 1 that we've reviewed some this year as well. So I'm going to subtract x squared from both sides. It's going to leave me with just 1x squared. I'm going to subtract 4x from both sides, and that's going to leave me with a negative 2x. And I'm going to subtract 4 from both sides, and that's going to leave me with negative 3, okay? X squared minus 2x minus 3 is equal to 0, okay? Again, you can put everything in the quadratic formula to work out great. The numbers are very simple, though. I have a feeling this is going to factor. Most of the questions they're going to give you in this book are going to factor. So remember, when you're factoring, you're basically looking for the FOIL problem that gave you this. So we can set this up and kind of work backwards here. We've got two binomials, 2 terms each inside parentheses. The first position times the first position should give me x squared. So it would make sense to have an x here and an x here. Okay? If you jump to the last step of FOIL, the number in the last position should multiply by the number in the last position. Those are both constants, no variables. They should multiply to give me that negative 3 value. So I'm looking for values that multiply to be negative 3. All right? If you think about middle steps of FOIL, you've got a term, outer step, x is being multiplied by that number. Inner step, x is being multiplied by that number. Those 2 terms are both going to have x. You're going to add those like x terms together, and you're going to get negative 2x. So I need numbers that are going to multiply to be negative 3, add to be negative 2. That would be negative 3 and positive 2. Okay? You should really check. Okay? If you multiply this out, that's going to be x squared plus 2x. What is that? Oh, no, that's not right. Sorry. Sorry. Numbers that multiply to be negative 3 and add to be negative 2 are negative 3 and positive 1. Sorry. And then they add to be negative 2. So check it. You get x squared plus x minus 3x minus 3. And notice that'll give you x squared minus 2x minus 3 equals 0. Now you've got something that works out. Remember, the idea of the zero product property, we've got this multiplying by this to equal 0. If 2 things multiply to be 0, one of those 2 things has to be 0. So either this is 0, or x plus 1 is equal to 0. Okay? 3 would make that equal to 0. Negative 1 would make that equal to 0. Negative 1 does not make sense as the length of the side of a triangle. So 3 is going to be our possible answer. If we fill it in here, x is going to be 3. X plus 1 is going to give us 4. And x plus 2 is going to give us 5. Okay? So the original right triangle that was described had side lengths of 3, 4, and 5.